welcome back to our JAM series. Again, before I continue, if you have not subscribed to our channel on YouTube, on Instagram, on TikTok, Maths Guru at Bishop Prince on Facebook, please go and subscribe and follow so that I can and click the notification button so that I can get all our messages. Now, having said that, we want to look at joint variation. Most times when we talk about joint variation, it's more about two different types of variation coming together to fuse into one question. In most cases, we have a combination of direct and inverse variation. Example, if I say P varies directly, I can say P varies directly to Q and inversely to the square of x. Okay? Mathematically, this relationship will now look like this. P varies directly with Q and also varies inversely with the square of x. Is that taken? For me to fuse this together, I can say P varies with Q all over the inverse of x. So we know that we cannot keep this relationship flowing as it is like this. So we must introduce a constant. What did I say? Introduce a constant. So that when we introduce a constant, the proportionality sign automatically changes to equality sign. So I will say P is equals to KQ all over S squared. Make this one equation 2, while this one is equation 1. From equation 2, I can cross multiply. I can replicate first. It means replicate means making both sides look like fractions. K, Q all over S squared. So what do? I cross multiply. When I cross multiply, I'll say KQ times 1 will remain KQ, and this one P S squared. So to make the constant the subject of formula, this becomes equation 3, this becomes my equation 4. To make this K the constant, what do? I divide both sides by coefficient of K, which is Q. So I will say KQ divided by Q is equals to PS squared divided by Q. So this cancels this, so my K automatically becomes PS squared all over Q. This is equation 5, and this is my equation 6. This equation 6 forms the relationship of my constant of proportionality. So if we consider a question that has to do with joints, so if we consider a question, yes, who will help me?
X varies directly as y.
If x varies directly as y, okay?
And inversely as z.
And inversely as z, okay? When x is equals to 5, y equals to 2, and z equals to 1. Okay?
What is the value
What is the value of x when y is equals to 5 and z equals to 2? All right, that's my question. So I'm looking for x now, known as x. From the first sentence, solution. From the first sentence, it told us that x varies directly to y and varies inversely to z. So I can combine these two, those direct and inverse proportions. So I will say x varies to y and inverse to z. So to eliminate this, I introduce a constant. Let my constant be k. So I say x equals to ky all over z. Okay? Let me make my k the sort of formula. I will say my ky is equals to xz. So my k is equals to xz all over y. Which is it now? Say, what is my x at the first instant? When x is what? 5, y is 2, z is 1. Let me apply it here. So I will say My x is 5. 5 times 1 all over 2. That gives me 5 over 2. That makes it 2.5. So the question now says, what is x? I should find x. My x is question mark when my y equals to 5, my z equals to 2, and my k equals to 2.5. So what this relationship x is equal to k, as we have it here, I will now say, what is my k? 2.5 times, what is my y? 5 all over 2. So this gives me what? 2.5. With this, now for x, 2.5 times 5 will give me 12.5 divided by 2. That gives me 6.25. That's the value for x. That becomes our answer.